Hi everyone, and welcome to this next bite-sized training for the MVQ Level 2 gas membrane installation. I'm Neil Selvage and thanks for joining us on this. Is our fifth issue, so we're working our way through the units stage by stage. Just one question that came up, somebody asked me how many units are there in each section? Well, both unit 612 and our following one 613 both have 7 units, and I've got some good news when we get to the end of the 7th unit. So we're actually here on the 5th issue of this. So today we're going to continue in our unit 612 and preparing to install gas membranes, and we're looking at selecting the required quantity and quality of resources. Now, resources is quite a big word. It covers a multitude of elements there. Resources can be your materials or your products you're using, the tools to do the work, valuable resources, and also the people that are doing this as well, their resources. So how we look at this under assessment, it's predominantly looking at the products, that they're sufficient for what the task they're undertaking in protecting the building against hazardous ground gases. So if we look at the National Occupational Standard, so here's our 4th unit. As I say, there's 7 of these, so we're midway through now at this time. So our first 4.1 here is predominantly looking at venting medium. Now it's quite interesting. It's got describe, state, outline. These are all knowledge elements where I expect the learner to be able to tell me what their understanding is, and in preparing what they should be looking for. So the reason I think, and I wasn't involved in the actual writing of these standards, which is now 10 years old with the revision 5 years ago, is why is it predominantly venting and priming and not installing the membrane? Well, the reason being is a lot of this is done by other occupations. So it might be done by a ground worker in his preparing the foundations of the building, that the ventilation is incorporated into that design. So when we look at the characteristics, the quality, the uses, limitations, venting is the primary factor we're looking at here. And one of the big problems we got here is you can see some cuspated void former vent mat laid in the correct orientation, the right way round. And also venting, has sufficient ventilation been provided around the building. So you can confirm this as an installer by looking at the drawing. Vents will often be indicated, but you can just double check to make sure they're there. I actually met a crew last year up in Scotland who were doing a really clever little trick with this. They were looking down all the periscope vents with a little microscope like a camera, and they could actually see that the cuspate, whether it was the correct way up or not. So that was quite good, and it was one of their checkpoints of their pre-start. So you can see how it works there. Often you'll find that if the venting is installed by others, especially the cuspate will often be installed the wrong way round, because that's the way it kicks off the roll. They can't physically roll it the other way. So often we find that the cuspate is in the reverse formation, and that is one major problem. Hopefully you'll pick up on that. And then you're back to the reporting. What are you going to do? There's going to be multiple parties that are going to be concerned about this. First of all, the site manager, maybe the ganger for the ground worker, and your company as well, because of the time and the cost implications in delays, etc. And you might actually get involved in adjusting these measures to make sure they're correct, because you're there before the verifier. If you're installing it yourself, then I expect that you'll be fully competent with understanding all your components and elements that make up your ventilation system. So we move on now to the next part, which is selecting the resources. Selecting is a task where I observe, I ask you, how has this been chosen? So often your material specification will be drawn up by the designers, somebody further up the line than yourselves. They've made this decision, it's been agreed, it complies to what the design requirements are. So double checking it is a key thing that I look for learners to do. So using either a data sheet, or often they have a tag on the rolls which identifies what it is. It's that checkpoint to make sure what you're putting in is what is on the drawing. Yeah. If it deviates, then we need to report it. It needs to go back through various parties, predominantly your own channels first, before it's raised with site. And then, maybe your managers will raise it with the site if there's a serious issue. But if somebody wants to deviate from that, that has to be changed on the design. So just be wary of that. And I do ask questions on that when I come to visit on site. Yeah. So we've got 3 remaining subunits here, which is, again, we've got state, outline and describe. Again, all knowledge. So the learner will be telling me what their understanding is of this, and we should be looking at how to use the resources correctly and understanding problems, the outline, potential hazards. So we're back on our health and safety a little bit there, but directly related with the products, and also how to calculate quantity and length and area and wastage. So the next 3 slides are going to cover these 3 subunits. So when we look at the membranes, understanding the problems that might be encountered. So here we can see in this top slide, I'm going to get the pointer on here now, we can see some product that's delaminated. This is just a sample where layers of the membrane have not bonded correctly in manufacturing, or they might have aged and caused a problem, delaminated, and one layer has actually physically come away from another. You get non-compatible products. So here on this particular footprint of the building, we can see that the DPM membrane is of a different color, or it's a different type of product to that's internal, which is a common design element, where the DPC will be designed possibly for high load reasons, high load capacities, and the membrane is of a different structure. Are they compatible products? Will they weld together and work together? Oh, we're rushing ahead tonight. The PowerPoint wants to move on. So just back on that, and we've also got contaminated membrane. So we might be looking at products where somebody's tried to fuse them or tape them and they've not been cleaned, or they've got debris on them. If you leave a membrane over a period of time, it could possibly give you a problem, where it's exposed to UV light, moisture exposure. It's quite a serious problem, and you'll find when you come to weld that often welding or heat fusing will fail at this point, because the membranes won't allow the contaminants will hinder that process. So just be mindful of that. One good element that I often see is people putting protection flaps or hems in their membranes if they know they've got a stop end or a day works joint, or a continuation of work maybe in a week or 2 weeks down the line, actually flapping that membrane to try and keep it safe. And then on the bottom right, we've got the damage in transit, which is quite a common one, where rolls get spiked. Here you can see the actual fork truck driver is using it on a pole, which is ideal really. It minimises the forks actually penetrating the front, which you sometimes see when they offload from curtain siders, that they just lift them up, unless they're on pallets and they've been packed well before they leave the factory. And the hazards associated with the resource, again, we're back onto our risk assessment, looking at our method statements and the risk assessments. So the COSH assessments as well will give us an indication of hazardous contents, which can be harmful if it come into contact with your skin, or inhaled, or digested, or contact with your eyes. So or fumes, vapors that might come off them products. The other things that might happen is what the resource is, how they behave in certain weather climates. So if it's icy, if it's wet, if it's very hot, membranes do all different things in different environments. So one particular example I often see on site is where guys are doing very good weighting down measures to keep the membrane in place. But if that membrane does flick up, it can be quite serious, to get hit on the side of the face with that. And the final part of this unit is looking at calculate the quantities and areas. So looking at the footprint of a building here, we can quite easily work out a plan or a flat dimension. We can see it in the red arrows here, a 2-dimensional plane. But often we have to encounter this yellow line, which is our 3rd dimension, which brings in upstands, changes of levels. So are they all being looked at and calculated in that? Because when you tote up all the, it could be 100, 150, 200 mil upstand. When you add all them into the equation, it could be a lot of material. Are you adding in, or has somebody added in for you, quantities of overlaps? So normally 100 mil, 150 mil, depends what's specified. Has that been calculated as well? That's a lot of joints that will be required. Then we've got all the pipe details, pipes and service entry points. Are they being calculated? Corner details, thresholds, and steel stanchions. Often that, when you start eating through, if you're self-adhesive detailing on these, you'll be getting through quite a lot of material, on every detail, X amount of square meters, 0.9 meters of membrane if you're using a 300 wide roll, or cutting down from a 1 meter roll to the sizes you require. So they're all things that we look at. Has that been calculated? What I always used to do was like to do an actual measure off myself, get my measuring wheel out and try and work out if there's upstands on the perimeter, what that perimeter length is. It's a bit of calculation for you as a technician, but we should be showing that we're not venturing into a job, because it's no good ringing up at the 11th hour to tell your office you've run out of material. Yeah. So that concludes that unit for us. We've got future bite-sized sessions coming up. We're going to look at the risk of damage to the work and the surrounding areas. So this is a bit of a hot topic with our gas membrane installation, where other trades are notorious for coming on and causing problems to our membranes afterwards. So, but that concludes today's session for us. Hopefully they're all useful. I know I've got some learners that are following up on these at the moment, supporting them as they go through. I will signpost you to these elements as we go through the MVQ process. In the meantime, if you want to contact me, there's my email address, my website address as well, phone number, running on the Facebook channel, and I'm also on LinkedIn. So hopefully I'll get some communications from you. It's one of our units that's going to come up later, communication, but I'm here. I'm looking forward to hearing any comments, and thanks again for tuning in, and hopefully this has been helpful, and I look forward to see you for the next unit. Thanks for watching. Cheers now. Bye.